Whatever that.
Yeah,
Go from there.
Well, no, use that normal conversation. I heard.
All right, hello everyone.
That was a pretty
My name is Peter, and this is Scott. And 2 weeks ago, we did a class called Adding with Electricity. It's an electronics class here at Sector67. We use that computer lab area over there. And first, we just want to give a shout out to, I think it was Patrick's kids. He's got 2 scouts. They helped us cut a ton of wires for like a whole day. The first batch of students you can see here on the right, they kind of came in, they were sort of our guinea pigs. It took them about 3 to 4 hours to put together this project. And they kind of showed us a lot of stuff that we might need to change in the future as well. And then also Jaden put up a really cool projector over there, and Chris too helped clear the room and all that. That all's coming together pretty good. So you should check it out. It's good.
Yeah, we legitimately kicked the tires on the classroom here, and we did a real class. So that now officially the classroom.
So yeah, today we're going to talk about what is a full adder, which is what the class was, the class contents, and what's next. I'm going to hand it over to Scott for what is a full adder.
Yeah, so the class is designed to give someone who doesn't really know anything other than how to add numbers together an understanding of how digital computing adds numbers, the basis for sort of like all of the modern languages. It's a mix of theory and hands-on. So what we're showing here is one of the concepts covered in the class, a logic gate circuit. And so we get into how do computers add numbers. We use base 2 numbers. We cover basic transistor theory. We cover logic gates, logic circuits, composing those. And then if you want to go to the next slide, we do hands-on breadboarding of an adder circuit, of a circuit that's called a full adder. So when you add base 10 numbers, you add the 2 numbers, and you might have to carry the number over to the next column. Well, computers add base 2 numbers, same idea. They add numbers, they might have to carry one over to the next column. So a full adder has an A and B in, 2 numbers, 2 digits in, and a carry out. You get into, and you understand as part of the class, what those logic gates represent and what they're doing and how. And then you build, as an attendee, there's 8 students in the class, you build a 1-bit full adder. And then you can see over here, we then, as part of the class, compose the 8 1-bit adders into an 8-bit adder. So it's you can see the power of kind of combining at scale a smaller process into a larger one. So this circuit here can have various chain numbers. The yellow is one input number, the red is another, and the white is output, and you can see the various adding and carrying that happens. As a part of that, as a class participant, you build and understand one breadboard, and then we wire those together with the carry out going to carry in of the next bit. So I think it's a little bit of probably enough on full adders, just to give a sense of what the class is. We go into all of that and basic transistor theory as well, resistors and transistors to make digital logic circuits. And so coming out of that, understand that and you can build logic gates and logic circuits always have to look full adder on a bread.
Just gonna go over the class contents real quick, just what's in the class. This is just a list. You go over electricity basics, talk about components, transistor basics, breadboarding, binary numbers, logic gates, how to build logic gates from transistor to resistors, then we do the full adder and then the combination. So this is all that gets covered in the class. So there's kind of a mixture of hands-on, there's some theoretical stuff, there's some interactive activities. We have a guidebook.
Yeah, we can pass this around. This is the class workbook, so we work through that. There's kind of some parts where you're doing independent building and parts where we're talking theory.
There's a bunch of images in there that kind of help you guide you through the breadboarding because what we found was with this style that we're doing, you got to be exact because if you're one off, it can throw everything else off. So it's kind of exercise in being very precise. We do some math in here as well, some kind of simple addition, as well as some truth tables here. Get done in this class. You learn kind of the basics of logic and binary math. Scott made some pretty cool animations that show how transistors work. I don't know if you want to describe it as
Yeah, so transit valve for electricity, so this shows kind of where you've got a little bit of electricity coming in, water as an analogy for that. So if you control a switch here, that opens some water flows. A little bit of water will open that and allow a lot more water flow. So that shows kind of what we call amplification mode of a transistor. And then you can go all the way to saturation mode or cutoff mode and use it as a switch on off switch as well as so we use water as an analogy for understanding sort of how transistors function.
Yeah, we got two more for pull up and pull down resistors too. Some nice
So that's just a transistor without kind of any current limiting resistors.
This is just kind of what a basic page looks like in the workbook as you're passing it around. It's kind of like a Lego set where it tells you what's used in each step. And it kind of shows you how to put it together. There'll be some tips kind of there, kind of saying if there's things you might get caught up on. This is what a general page looks like. And then we also did some interactive things. We did a human computer. We had people wearing and becoming logic gates. And then they were saying if they're getting a 0 or getting a 1. We did have a human full adder, and it did work really well.
Great.
Yeah. You don't need the breadboard, the whole board. You can just feed everybody these and little 0s and 1s. And probably terribly ineffective, but it works.
Yes, adding with humans.
Adding with humans.
Does it know how to do AI?
It was not even A, it was just I.
And yeah, that's the result, the full result over there. So yeah. What we found with this class was we had trouble everyone getting done at the same time, so people didn't get to see the final product. But we kind of have some plans that kind of have it so everyone could finish at the same time. Yes, this space is getting pretty nice up over here. If you want to join the next class, it's on March 14th, 2026.
Friday.
9 a.m. to 1 p.m. It's a Saturday, so it's at Sector 67. That should take you to the register if you want to join.
I'm gonna pass these around. It just shows this idea of, as Peter was saying, when people were building the breadboards, if they were off by 1 to start, then it was, the breadboard really is optimized, as you can see in the image there, to fit the full adder on. And sort of standardized diagnostics of like, go check this pin and see if this is happening. So we're using sort of these templates to overlay on the breadboard as a kind of a poke-yoke type technique to reduce the number of errors possible by just providing that template of what components go where. And one of the very interesting things we learned, thanks to Bill, I don't know if he's here, but Bill's red-green colorblind. And you can see our new board is black and red, but we use green and red for a bunch, and to my great shame, because I do a lot with accessibility in my professional work, totally had a blind spot for accessibility of this class, so to speak. Yes, a lack of a blind spot, I guess. But yeah, so we learned a lot. We redesigned based on that question.
I'm not gonna do it again, but I see you increase the price.
Oh, we did increase the price. So the first class was $10. And we've increased the price to $50. So
What do we do with surge pricing?
So it's a 4-hour class with 2 instructors in a facility. So what is fair pricing for that? Hard to say. But we're going with that for now. Yes. We have
Dynamic pricing.
which means God, you better get in on this one because who knows what the third.
There's only 8 blocks of this progression.
Exactly.
They're following an adder,
Yeah, it's binary.
How do you produce the render of the breadboard there?
Yeah, so I used a tool called fritzing, which is it's a kind of a electronic CAD tool that has a breadboard view, sort of logic circuit view, and you can also do PCB layout on it if you want. So it's like a KiCad, but it includes a component that is a 2-scale breadboard view, which is really convenient for the templates and stuff like that, because I just needed, I could literally generate a PDF out that was to scale that I can then print 1-to-1 on the bread. So fritzing, I don't necessarily recommend fritzing for anything other than that. But it does work nice for layout bread.
So did it fully automatically lay out the breadboard, and you have to?
No, that's all manually done. In theory, I could do this schematic view and also organize all the components and test if I use another spice type program for. Anybody else got any questions? So. Yeah, we could go back, I don't know.
If someone were to accidentally move one wire over there, how long would it take you to figure out which wire was in the wrong spot?
It might take a while, but with the templates, it would be a lot faster. All right, I'm gonna go back, Peter, and wait, just to demonstrate the full adder, I saw you had some numbers here. So if we want to demonstrate how the adding is working here, we can do just the far right,
Starting from this one right here.
Yeah.
So I'll get a 1, get 0, we got a 1, a 0.
other way actually. I think.
Oh, the other side.
So this is so that start with a 0.
Right over here. All right.
And this only stop begin, you
So
get 1.
0, and then
Yeah.
1, 0, then 1, 1, 0, and then 1.
Yeah,
Looking right, and the second one we got 0, 0. And we're gonna do 1, 1, and 0, and 1, 1.
okay, and so we got our white output on the bottom there. We should actually have digital, we should have decimal representation of these errors, because this means nothing to you if you don't know, but those two numbers at the top add to the number. If you come to class, you'll understand. Other questions? I'm gonna just put this on.
One more question.
Um,
What's that?
have you ever used like Tinkercad, electronic building tools?
Tinkercad.
Because they had like the,
Yeah, Tinkercad's by Autodesk, if anybody's not familiar, it's really good for younger people to learn CAD functioning skills, like basic CAD. Recently, though, they added a physics engine.
Yeah.
You can set up a bunch of stuff and you can turn on physics and let it all fall down. Or maybe standing up. They have a Minecraft mode and they have an electronics mode.
Oh,
Redstone.
There's splatters in Redstone, if you look them up.
Well, the Minecraft is a separate mode than electronics, but yes, they could add the two things together. But yeah, you can do Redstone full on electronic stuff there.
Okay, I'm just gonna see here if I can.
What these guys are really doing is they're gonna use all the class participants' work, and then they're gonna slowly build a supercomputer. 8 bits at a time.
Yeah.
So-
Just to put it in perspective,
how big that
you
is.
use 22 transistors to make each 1-bit full adder, and a modern CPU would have something like 200 billion transistors on one chip. So
You gotta wait it out.
it'll be a while before I get to the supercomputer at 22 transistors.
4 hours for 8 bits. How many hours of thinking and labor do they need to get? A
8 million people.
lot of few.
There's some really interesting folks on YouTube that have done like a 4-bit basic computer on breadboards with the what's that?
Have you ever seen Ben Eaters?
Ben Eater has done some stuff, yeah.
Whole computer on the breadboard.
Yeah, there's some people that cheat and use integrated circuits instead of transistors, you know.
How many amps does your display drawing right now?
That display is drawing probably at 1.34 amps.
Yep, 1.282.
So it turns out big transistors are kind of costly on the current front. That's the other interesting part. All right, well, thank you guys for sharing.
$500 billion machines.
We'll get up for lithography class then in another couple months or.
Or whatever you open around silicon.
That could be an option for you. All
Kind of gross look.
right, thank you guys.
All right, thank you.
Well, it's gonna put in my noses.
I turned your controller on, so you can drive it up that way if you want to. Everybody should put on their safety glasses, you're gonna get shot in the face with a ball. But it'll give you plenty of warning before you get hit, so it's right. Peter, I got your phone up here too.
People are talking about how to take it right from. No, yeah.
Take it.
And take it, okay.
Guys, we're on.
Yeah, you guys are up.
You pulled the slideshow, you had thoughts.
Slides, you don't have any slides.
Look at the
You
slides.
guys are fine.
I'm not gonna use those slides, Will, weird.
No, my slides had the comics wait, but Jack,
I'm not Henry, Will.
the comic stands too much for you.
Alright, there is all the information anyone needs. You guys got it working?
Oh.
Or do we break it?
We're very careful.
Yeah, it's like a baby.
Very nice baby. Drop it.
Oh, there it goes.
Who won?
Everyone's putting some loss.
Rather bring all of them up there.
Yeah, you really said that.
Alright, mom, this way.
What are they doing now?
There. You know, it had a whole lot of.
Ridiculous.
So I was taking the robot, Will.
Okay, but. Hi,
Alright, you guys wanna say who we are?
we're not wearing our shirts right now, but, we're the robotics team, Madison East Engineers.
What are your names?
I'm Will.
I'm that kid.
Jack.
Guys.
This is
So-
Dingus.
Yeah, this is our first year doing this competition, we didn't, this isn't our robot, it was, there said that, but it was this, it's called FTC, for challenge, yeah. So, the goal this year was to make a robot that could pick up balls. They call them artifacts, like these, and fire them, into goals, so, I don't know if you have the goals still.
All
but-
gone, sorry.
It was a really weird challenge. The balls are very big. These balls are very big and bounce really easily, so it's kind of hard to be able to plow them and move them over. As I said, it's our first year, so we're not very experienced. It's just like
Wilton, like mom.
used to do this. I don't know. Scores for how we did. We won 4 matches, lost 2. For our first time, that's pretty good. We got 11 plus in our competition. I have 28, so we got top 50 because.
These are national rankings up here, so this is
Yeah.
all of the FTC teams.
Very
And then, yeah, a little tiny bit of backstory, I don't know if Sean made it or not, I think he's.
This guy.
Oh, there he is, good job, Sean. So Sean, what year was he in school? Who knows, 10 years, 10 years ago, yeah. So 10 years ago, Sean's daughter was interested in robotics stuff, and we had previously done some robotics programs here through First Lego League, which is a team, a group that's one level below this, which actually there's a sign on the wall over there from my team from a long time ago. And so we spun up a first tech challenge team, found some friendly folks willing to give some money to buy some stuff. Since then, I think we've had 8 years of teams. However, there's a big break over COVID, and so we rebooted the team last year. It's in partnership with Miss Chin. Cynthia Chin's really well known from East High as the cow teacher. She's the really scary cow teacher. She gives a million problems and is hard grader on all that. So consequently, she used to funnel all the students over here. The bad news for us though, she retired last year. And so these folks are all here because they heard about it through the engineering club.
Your team.
Yes.
Also, that last year are all.
Yeah, the entire team of last year was seniors.
The most experience we have is a little bit of CAD, and that's the end of it. That's all we could do.
So for the
You know how to do basically.
so last year the team got 13th. And this year the team got 11th. So my God, we just need everybody to retire more often. Literally.
All right, never
So
come back.
the team last year got picked for like competition that was higher up. It's like 6 top teams choose 6 partners to go with them to the next rounds. Team last year got picked for those because they had a really good coding that made it the autonomous mode. So like first like 30 seconds in the match, you can't touch your controller, but you can write code that makes your robot move on its own. So that can fire balls and move and pick up things. And they had like one last year. We did not have one this year, and our robot was kind of weird. So we kind of got that.
A little
It
bit.
was for
We can move. That's the end of it.
Exactly right.
Yeah.
we're gonna sign up the comments.
See how, yeah, it's gonna drive probably right up to the wall, everybody. There you go, maybe.
It was something 5 points before, so.
It's 3 points. So then, you guys wanna shoot a ball somewhere? You can shoot a loop, then that's fine. Adrian's right there, he'll catch. Doesn't matter. Adrian will. Very reliable. I'm trouble. You can throw back, yeah.
So every single round there was a order and you can fire if you fire the balls in like purple, green or something, or purple, green, purple, they get you more points. When you fire them into your goal, they were lined up that way at the end. So we use manual loading where a robot would plow them over to someone, who would pick them up and load them in that order. Some robots pick them directly, but we don't have enough time or experience to.
They're also going to fit it in an 18x18 square.
Yeah, that's
Yeah, it's kind of funny, it's just a bit of plywood and it got it to 11
Somehow.
place. But
There's also a face.
right,
At
got
the
a
very bottom.
blue eye on the front.
Can't really see that.
Stop picking the robot. What?
This is not one of your rounds, but the competitions are streamed on YouTube, so you can get a better sense of the goals these guys are shooting into. And they occasionally shoot bystanders, which is the other part of the entertainment.
This is that conversation.
Yeah.
Yeah, so we did not have much time. So the other thing is they had about half of the typical season time to build a robot, just because there was some coordination things with the school getting these folks aware that they could do this. And so at any rate, yeah, some of the bots are more sophisticated and they had more autonomous routines. There are some April tags around the perimeter of the course, so the robot can use a camera to figure out where it is. And so you can program very sophisticated stuff, and also the interesting part though is reliability turns out to be really important. So in this case, having a basic robot that ran all day long and was super reliable has a lot of merit, as opposed to building a really fancy thing that breaks all the time. So there's kind of a balance to all that. But you'll notice all the robots generally take like the full area. You're given an 18x18x18 cube this year, and they usually end up pretty cubed, trying to take up as much space they can. This is the first year they allowed you to run into other robots. Previously, it was hugely forbidden to like run into the other team at all. If you ran into a robot, you get penalized. This year, you could play defense. You could run into each other, and so you'll notice some of the autonomous routines don't work very well because they keep getting bumped into. So the other team will just run into them right when they're trying to spin up to launch, and the thing will either miss or won't launch at all if it's off target.
Yes, that was
And
the.
our book being made out of plywood made it kind of very lightweight. It's made it easier to be pushed around. But for some reason the wood made it pretty durable. So it got pushed around a lot and it survived.
Break off now.
Yeah, didn't break off.
Teammate we had once, the 2 rounds we lost, our teammate, the 6th graders made a robot. It wasn't a very bad robot, it actually worked pretty well. We ended up hitting them halfway through the game. Actually pretty early. Yeah, the drive kit fell off one of the wheels, they couldn't move, but we lost that.
Yeah.
Not by much.
I don't even have people with flies branded. Okay.
Yeah, it's a box.
Yeah.
Your question back here.
Oh, at the end of the match, there's always like a parking, like,
Yeah.
how does that, like, what are the rules about that?
If you park within the cube, like fully in it, you get 5, maybe 10 points. And then if you park someone in the cube, or at least any part of your robot's in it, that's 5 points.
So, well, it's like based on surface area, like on the ground. So like there were robots that would lean like all of their bots over on an angle and have like a corner of the robot on it, and that would count as being fully parked because only a portion of it was still in the cube, and then they'd have another one that could be fully in there too. So
Yeah, but like we would get, that, it was like the base, it was the 18 area, but we had to have rounds sometimes where one of our teammates would be for each side of the cube, and we had a corner of a robot they could shove in a little gap where they did not fill up, and that little corner would count towards the full kind of worth 5 extra points that we got for the inside. So that would be good.
Aaron?
So for the defensive measures, was that you were only allowed to run into other robots, or can you actually like implement like I don't know. Grab a couple of stun guns and they'll short out and fall out of the doors.
Just mention damaging on the robots. Brother robots did get damaged. Those parts that fell off and things. But our robot was very durable and stuff, so nothing fell off, nothing broke. But we could also be pretty fast and kind of a bigger thing, so we could slam into a lot of people. But yeah. So as long as you didn't pin the enemy robots, as long as they couldn't move, as they couldn't move or couldn't get out of the situation, then you wouldn't get penalized. So you could slam them into things and move them around as much as possible.
That's the team that you knocked the up, I believe.
One of the funny things, every single goal has a ramp and a gate at the end. If you open that gate, all the balls fall out. If you open the gate for the enemy goal, you get 10 points. You get 10 points moved off. That's like 10 foul points to the enemy team for opening the gate, and then 10 points for every ball that comes out. In one round, someone opened that gate, I guess, and then like 100 balls fell out. So their team they'll get 212 points because the enemy team got 150 foul. Because they opened it. So it's also legal to push the enemy robot into your gate to get those points. So that is the legal strategy.
Here you can also consist keep running into the robot.
So no, we're.
I'm doing
For shooting the balls,
So
how
you
do you control, is that set?
Yeah, you could explain how you had two different modes to shoot.
Like, it looked like you could shoot the balls at different
Yeah, we
heights or
have a
different
variable
velocity.
RPM on the motor.
Yeah,
Is that controlled manually in the
Yeah.
moment or is
We
it
have
pre-programmed?
two separate controllers. We have one for controlling the motors and
this
the
one controls driving and this one controls the firing.
But I mean, is it ramping up and you're like kind of timing it out?
You just turn it on.
Yeah.
Or can you like
Yeah.
consecutively shoot them like in the same spot?
There's two presets, so they got
Okay,
two speed
yeah, that's
preset,
what-
but then it's fully adjustable, so if it's off, they can adjust it up or down, but.
If we wanted to shoot it from or we had it at 900, if we wanted to focus from longer, that's that.
Or 1400 close. So we did a lot of testing. So our far mode was like from the corner, was like a 1400, and then from kind of close to the goal, so about here was 900, and we just had the testing, and they had practice like of this version. They had practice versions there that we could do in between rounds. So we kind of did a lot of testing then because get our distances down. Also definitely helped us with our score.
Any other questions from anybody? Anybody ever do this as a younger person?
I want civic.
So yeah, First Robotics has been around for decades now, quite a long time. It's Dean Kamen-ish. Dean Kamen's in the news for other reasons right now. Good. At any rate, first been around for quite a few years. It's there's a grade school to middle school team set called First Lego League. This is First Tech Challenge, which is intended for middle school and high school. And there's First Robotics, which is like a 36 by 36 by 36 cube. The downside is First Robotics is about $10,000 to $15,000 minimum to buy all the stuff for the team. These guys' registration and the registration for the competition ends up being about $600 or $700. So just to exist, you have to spend $600 or $700. And then the kit is actually partially halfway funded by the state. So Wisconsin Department of Education has a grant. They cover half of the expenses for the teams. So that was the early question for these guys was, were they willing to compete? Because if they didn't compete, it would cost me double. Because if I registered, then we'd lose the DPI grant if we didn't show up. And so once we had assurances that at least one person would be there to drive the robot, which all four folks in the team made it, which was awesome. It meant that I would lose $400 for no reason, so that was good. So thank you guys for saving us money.
When you say a kit, like, do they provide you with a box of materials and you're only allowed to use those materials?
You're allowed to use anything, but you're given a baseline box. The only thing that is completely strictly regulated is that the controls need to run on an Android phone. And then in this case, we bought this as a Rev Robotics controller, just functionally a phone.
Yeah.
And then the robot is the robot controller is the other part of the hardware that's required. So the electronics have to be they're electronics.
So then you actually, but for building materials out, you use anything.
Yeah, Sean every year makes sure there's wood on our robot, and our robot's taking one with wood. Yeah, so it's awesome.
Yeah, we do
Fire
that, so-
competition, everything is like handmade, like including like even down to the Like control it, there's no preset that you're allowed to.
Yeah, you can do all sorts of stuff. Yeah, just where a lot of the cost comes from. Awesome. All right. Well, thank you guys for filling out the that. Very much appreciate it. You guys want to take off? You're more than welcome to. If you want to stick around, you're awesome. You're welcome to. There's 2 more presentations. Marc, you want to go next?
More chairs back here.
I guess you can just come on left and just 2 chairs for you.
We're stunned on each side.
I wouldn't mind setting up an NHRL
I
habit
mean,
league
here's
bot.
it on wood, like a little bit loose, and I would, let's go over up there, no, that would help, but so we didn't want anybody else.
I wouldn't mind setting up a battle bot. That would be great.
Alright, so Marc's here next to talk.
Competition.
Hi, y'all, I'm Marc Severson, and I wanted to talk a little bit about roasting coffee at home. Another low budget problem because I like coffee and I like adding things for low budget or having coffee on a low budget. So
Use the microphone, please.
yeah.
There is no microphone.
I can try to talk louder.
Yeah.
But yeah, so first question is why would I guess this is simple right here. Why would I want to roast my own coffee beans anyway, right? So the first guy I ever met that roasted their own coffee said he did it because it was cheaper. Like, okay, that's great, but it didn't seem to cost that much, whatever. But it actually turns out you can buy green coffee beans for about half as much as roasted coffee beans. So that might be a reason. But I thought it'd be fun to try it out. So I tried it out. And the reason I like the roast coffee, as it turns out, is that I like my coffee roasted really fresh to me. Like if it's over a week, like that's kind of old coffee. So within a few days, it's great. And if I roast it myself, it's really easy to have a supply of freshly roasted coffee. So I think it's tasty and it's fun and whatnot. So what do you need to roast coffee? So this is like, there's a lot of fancy ways to roast coffee, but this is like low budget. And so it turns out to be really simple. And I thought like, oh, I'm gonna try it out. I'm gonna kind of make something cool and design something. But it turned out it works so well this way that like why? So it turns out like the heat gun and a pan, and you're pretty much ready. So and I use a sheet pan and to dump it out. And you also need coffee, of course. So it turns out if you ask nicely at a roaster, they often will be willing to sell you green beans for about half the price. There's also some places that sell it online. One of these guys, this guy wrote Home Roast Coffee, is in Cross Plains, and you can actually pick it up there or put that in its number up if you want to. So a lot of ways you can get it. Still, about the same price whether you get it there or not. And so this, in this pan, you can do a small batch, and this will get me through like a week or so. But if you drink a lot more, you might have to figure out how to use like my dryer drum, which is over there. You figure out how to make that into a roaster, then you can do that. But I haven't done it. You can apparently use a popcorn popper, an air popper for this. But it has to be the kind where the air comes in from the sides, not the bottom, otherwise it catches fire. So that can be done too. It's another low budget way. And that Home Roast Coffee place and some other places, they sell a bunch of other stuff you can do on a stove, or they got whole roasters and things like this. But like this is just so simple. It just there's nothing to it. So throw it in a pan, and point to heating the beans. Pretty much it. Doing this outside is kind of good because there's a lot of smoke and the husk goes through. So with any luck, this will play in a moment when it's started here. And this heat gun is like old and terrible. It's like I used it one time to heat up a ball joint on my car, and I just propped it up under there. Came back 10 minutes later, and the air was actually coming right back down onto the heat gun, so it's all melted and stuff. But it still works. And I got it for free from my place that I worked because they were getting rid of it like 10 years ago. So it doesn't have to be very big. So yeah, that's about it, you know, swirl the stuff around, point the heat at the pan, do this for a while. Yeah. And it seems to work in cold weather and hot weather just fine. So you do this and oh yeah, we got a question back here.
I was actually just gonna ask how long it usually took.
Oh, there you go. Perfect. Well, this one took like 9 minutes altogether. I think it's done in about 6 before. Kind of depends how close you hold the heat and stuff. But yeah. So like 5 minutes later, you get to the first crack. So you do this and you get this sort of popcorn sound. That's first crack. So it's the sound.
Are they actually popping out of there?
No, it's just you hear the pops, but it's actually mostly staying in there. Most, yeah, some occasionally I'll lose some. It's more because the agitation than anything. But you see, you probably see the husks though flying off in the leaf.
Oh, okay.
Yeah, so they're really light, so they fly everywhere. Yeah. But yeah, so this point, like it's a light to medium roast, depending where you pull it off in here. So if you like those pretty kind of light roasts, this is where you want to take it off somewhere around here. You just keep going, and then like that first crack stops, and then you get to the second crack, which is like this, like more frequent, lighter little pops, like a different kind of firework. Yeah, if you know what that is. If you know what I'm saying. And you get smoke here. After a while, you get this oily sheen on the beams. So this is what that sounds like. So that's I should have, yeah, the mic didn't pick up the popping very well because obviously it's closer to the heat gun than the pan. You can kind of hear it. So it turns out that there's these signals to tell you how far it's roasted, and you don't really need to do like fancy temperature things because they're like, oh yeah, I'll use the infrared heat gun. It's going to be amazing. Yeah, you can kind of tell where you are just by looking and listening. So this gets into like French roast and then to Italian. And then if you kind of go to the end of that, when you get the oil on there, it's like a campfire roast. That's what EVP calls it anyway. When they sell something like that, so you get like a whole range of roast there. And then, what I like to do is just dump it out a couple times. So I get a few different ones that I can taste and then mix them together so I can kind of fine tune and make what I really like. So then you've got your freshly roasted coffee, and you can go in and make a nice cup. A few other coffee hacks, low budget. Turns out you can make a pretty good espresso with a really cheap machine. And this machine sold for like $99, like when it came out, and I got it for free as a gift from work for working on 15 years. So, but it turns out they all have the same pump inside. My brother has a fancy one that cost him many hundreds of dollars or $1,000 or whatever. Got the same pump. Yeah, you can actually do a lot with a cheap machine. These cheap machines, they like to put these valves in so it'll create the pressure in there, and you can take that out. It's meant to make it more foolproof, but if you want to, so that it doesn't matter so much how you grind it, how you temp it, you take it out, then you can get a little better cup out of it. I stuck this steam wand off of Amazon onto it. That's better than the original cheap one that was also kind of foolproof. And this is what the heater looked like after 7 years. I had to pull it out. I had to get it, I just got another cheap machine off of eBay, so I had parts available. And finally, last little hack here is grinding is really another place you can spend hundreds of thousands of dollars on a grinder to get to really great grind. When I got into coffee, this hand grinder was like the only bird grinder you could get for cheap. So I did that. Problem is like one click on this adjustment on the right side, the left side here. One click on that was like from way too fine to way too coarse for espresso. So I started shimming it and then later, I put numbers on the net so I could tell where it was, and then came up with my older kid, came up with a design for this 3D printing these plastic things to replace the metal in here. So now you got 10 different settings where there used to be one setting. So that was a kind of a fun hack. Turns out they've made these better by now, so there's better adjustability and they got better guidance, and you can still get them for cheaper price, but that's what I got. Yeah.
Have those 3D parts ever worn out after use for a while?
No, they've been hold up great. Yeah, fortunately, yeah, they don't really hold much. They don't have much stress on them because they're just keeping that nut in a specific spot, really.
Oh, yeah.
Yeah, although it's a little bit. It's gonna break someday because they're a little too thick and thicker than the metal things. They push that handle up. Yeah. Anyway, at some point the shaft is gonna round itself off, but we'll see. Maybe it'll be time for a new grinder at that point. But yeah, so that's enough to get you started on roasting your odd coffee just for yeah.
You can burn the beans?
You could. I mean, yeah, if you get to where they're like really oily, you kind of like if you keep going. Like I did try sticking them in the toaster oven once in the air fryer setting, and yeah, I set up the whole thing on fire. That was so you definitely can do that. Yeah, in the pan like that, I've never actually set it on fire, but it's probably possible. Yeah, actually, I know there was a EVP had a fire a couple of years ago in the roaster, but I think that was it's probably like stuff got caught in the exhaust or something. Yeah.
How much coffee did you drink today?
I was just thinking that.
Yeah. I don't actually drink that much. I usually have like 1 or 2 shots a day of espresso, and I make it. Yeah, maybe make it an Americano. Sometimes on weekends make cappuccinos. But this is like a typical Saturday. That my wife and I will make up like 6 shots of tasting different shots and comparing different roasts and different coffees that we got here or there. So yeah, 6 on a weekend is typical. Yeah.
So you don't do this every day?
Sorry.
So you don't do this every morning?
No, I don't do it every morning. Yeah, about one. If I'm only drinking this, it's about once a week I'm roasting, I guess. But
Yeah, you're up for the rest of the week.
yeah, yeah.
So really after a week, it's no good.
It's not as good. Like I don't know. I feel like the first 2 days are its best. It's it's still pretty good after that. Yeah.
This might be an unquantifiable question. What do you think is the taste difference between older and newer roasted beans?
I just feel like it's more like the tastes are more vibrant. There's just more to taste there. Like, I think it just kind of gets more mushy and harder to it's harder to detect those different tastes. So like I don't know. Yeah, it's just I mean it's sort of like something else getting slowly getting stale. It just gets less and less interesting. That's how I describe it. Yeah.
So do you have a sense of how old roasted coffee is at a grocery store?
Great question. Great question. So yeah, this is interesting. So I think I stumbled, but one of the reasons I stumbled into this is I found that when I bought coffee in certain places, I liked it a lot better. And those were places where they usually had the roaster right there. And I started to eventually, after a while, put together like, oh, some of these places will give you the date that it's roasted. And then you know how fresh it is. And I realized that, oh yeah, if I get it from these so I like EVP. If you go to the where they have the roastery in East Wash, then they'll they roast some of the stuff they roast like every day. Some of the varieties were like maybe rarely more than a week old, but you can you can find out. You can ask them what's the latest thing if they just did it or whatever. So I like that, and we've gotten like you get like bulk bins like Woodman's. Like it turns okay because it's Woodman's, but still it's a lot longer. I love Jenny Street Market, but I found out that one time I got some decafs from the bulk bins there. We tried them out, like these are these aren't as good. And so the theory was like, well, okay, the decaf things probably don't turn very well. So those are probably the ones that are the oldest. And oh, and yeah, my my wife's favorite horror story with coffee was that the ground coffee that I left in my office desk, it was there when COVID started. So I brought it home like 2 years later and made a shot out of it. And she's like, this is the worst thing ever. So like when we talk about yeah, that was famous for how bad that was. Yeah.
But made like like the old beans, 2-year-old ones, they got like mold or something, but it's like
It just change how they taste. Yeah. Yeah. Just get less and less good and eventually get pretty bad. And not old.
How perishable are like the green, like roasted beans?
That's another good question that I don't have a great answer to. I do have some that I had around for a long time. For like I had them for like a year because I was using them for a while, and I got some others. And I feel like they aren't as good, but mostly I find out if I like sooner I roast it, the better. I mean, if I roast it and have it right away, it's good. So, and I figure that by the time it gets here from like Africa or Asia or Central America, that supply chain isn't fast and it's just sitting in a burlap sack. So seems like they hold up pretty well, but that's a whole other thing to explore, right? Yeah.
Have you considered becoming a coffee influencer?
I have not, but if I do, this will be my launch.
Or a coffee podcaster? You definitely.
coffee SMR.
Yeah, the questions.
Anything else?
Are you gonna charge more or less than $50 for the coffee class?
First time in 10 months.
Yeah.
Cool, thanks.
All right, thanks for sharing. All right.
Samples?
What's that?
Samples?
Oh, good question. So I got the last presentation. I'm going to talk a bit about, we bought a new machine that just showed up. So this was, a while back, I think this was June this past year. Weike is a laser cutter manufacturer. They actually made the laser that we've had for about 10 years over there. It's a 150 watt CO2 laser. So we're familiar with the company as an OEM. They're a manufacturer for a lot of lasers. So they make the lasers and they put whoever's logo that they were buying to that batch on there. So Weike manufactures a lot of the machines that you see. They just don't have their name on it. So this is like buying straight from the factory. And then when you buy a OhmTech laser or whatever, it's coming from their factory. It's just got a different brand and a different design. But there's a pile of manufacturers. At any rate, CO2 lasers about 10, 15 years ago became a thing because they innovated the ability to seal a tube. So prior to that, you had a flowing gas laser. You had to have a vacuum pump on one side, and you had a bunch of bottles of laser mix gas. That was really expensive, very specific blend, and it bled through under vacuum. Then you run a high voltage source through it, and you'd get a laser. And they're glass tube lasers. They're relatively inexpensive to manufacture, but you needed a vacuum pump and you needed a bunch of bottles of gas. So like 10, 15 years ago, they figured out a reliable way to manufacture a sealed blend of this laser mix that would run for like 3 to 5 years with no vacuum pump and no bottles of gas required. You could buy a laser from a Chinese manufacturer, they could mail it to you. You'd get the laser, you'd set it up, and it would run for years. You wouldn't need extra blends or gas or whatever, and when it wore out, you buy another tube. They did that by having a gas reservoir around the tube. So the tube fired the gas inside this plasma resonator chamber with a full mirror on one end and 80% mirror on the other end. So most of the energy bounced back and forth, and the 20% leakage is what made the laser. And then what they did is they had a reservoir about this big around the perimeter of that plasma tube, and the gas slowly made its way through. And the trick was they had a really high gas purity, and then they put a gold catalyst in the inside of the plasma chamber that would reassociate the CO2 that had got split in half in this plasma, put it back together again. Very long story short, that's why CO2 lasers became a commodity, like hobby type thing. You just go buy one. Yep.
So is it like kind of how a refrigerator does, where like pumping the freon constantly over, so it never really like instead of so like the ones before you needed to replace the tanks was like it was the gas being expelled out of the machine. Then this in the CO2 machine is not being expelled, it's being put back in the same over and over again.
Yeah, it's a good analogy. So the idea is the refrigeration process is closed, and so you're just pumping this fluid in a circle. This is similar in that you had a closed glass tube. The catch was that based on the purities of the gas, eventually you get a bunch of dissociated atoms, and they kind of spoil the blend. And so just like a refrigerator, if you had some contamination at the beginning, it would turn into acid and eat your refrigerator. So this is very similar to that, in that you have a glass tube. At any rate, long story short, recently, about 6 or so years ago, you started to see on the market this idea of a fiber laser. So a CO2 laser is this glass tube, it shoots an invisible beam out, and it bounces off some mirrors, and you aim it at something, and it destroys things. So awesome, good, useful thing. A fiber laser source uses a different wavelength that can travel through a glass fiber. And so you can take this wiggly noodle of glass and you can aim it at a thing and you can destroy things in the end of a glass fiber. But because it's a different wavelength, it interacts with different materials. So CO2 lasers could do paper, wood, plastics, but it wouldn't touch metal unless it was really high wattage. Then you had to have it circularly polarized so that when the metal started to melt, it didn't bounce all the beam off. Otherwise, the second it started to melt, it turned into a mirror and it bounced all your wavelength away. So CO2 lasers were kind of tricky to get them to work. So like 6 years ago, fiber lasers became a thing. About 4 years ago, a local manufacturer had bought a prototype 500-watt fiber laser. They were going to do something with it. They decided not to. They donated it to us. We set it up in a gantry. The trouble is that it's really dangerous. You can't see the wavelength, and it can aim in any direction, because if the fiber falls off and breaks in half, or who knows what happens, it does bad things. So, yes.
Is it infrared?
It's infrared. So the idea then is these fiber lasers started to proliferate, become a thing. And fairly recently, I reached out to a manufacturer and said, hey, I have a 500-watt laser. If I want a 1500-watt laser, if I want to replace this, how much would it cost? And they laughed and said, we don't make 500-watt lasers anymore. Like minimum is 1500 and up. So your thing is tiny and old. So in June of last year, Weike released a from manufacturer direct to consumer Kickstarter project. I'm not naive. I don't support Kickstarter generally, so I did not buy a Kickstarter laser, even though Weike is pretty trustworthy in terms of you kind of know what you're going to get. So this company went out to the internet and said, we're going to make the world's first 6-in-1 laser. So the idea was they took a welding laser supply, this thing, which is a handheld laser welder, which can clean, weld, and cut, and then they put it onto a gantry. So the trick here is that because this handheld part already kind of has a 90-degree bend to it, you could make it fit inside of an enclosed machine because it had the 90-degree bend integrated into it. A regular laser, the fiber lasers previously needed like a 1 meter bend radius. They need this massive arc out of the top of it. So you need a really tall machine to take up a bunch of space. So consequently, they released this thing and said, hey, we're going to sell this machine. You can buy one. It'll cut metal stuff. You can weld stuff. You can handheld cut. Why would you do that? I don't know anymore. But you can clean stuff. And then they're going to stuff a CO2 laser in it as well. So they put a CO2 laser in there. Hang on. All right, go for it. What you got?
Are you able to like easily remove to like, take off like the handheld part, or is there like a process to like plug it into the laser welding machine, your laser CNC machine?
It's down here. Hang on. Oh, where's the video? It's they say it takes 30 seconds to change. So essentially, somewhere down here, there's a picture of the guy unhooking it, pulling it out, and then welding with it. So it clips it. Yeah, they gotta. If you're gonna go with a Kickstarter, you may as well convince your customers you got it. So this thing on the right here is the fiber laser, and it needs a floating Z, so they have an actuated Z for the fiber head, and then the CO2 lasers on the left, which is fixed focal plane, so it doesn't move up and down. You move the whole bed up and down. At any rate, they released this thing. Cool. They made a bunch of money. They started shipping these, and then I caught on their website that they had devices available in stock in LA in 10 to 15 days. This was in November this past year. So this is when they were still delivering the ones on Kickstarter. And I was like, this seems like a good option. We'll just not support the Kickstarter, jump the line, and just buy a machine if they have them in LA.
Price looks a little bit.
Actually, it's not. The price on here, if we look down, this is the other funny part. It's actually cheaper to buy it later than it was to buy it on the Kickstarter. So this is the M3 Ultra. So the price is exactly the same. So anyway, I did what you should do, and we went ahead and bought the machine on the very same day. And so then, of course, drug out it's not actually in LA, and maybe we'll ship it here coming up pretty soon. We'll get on that as soon as we can. And so it took a while, but it just showed up. I ordered it hoping we'd have it by Christmas, and we got it just yesterday. So
I had a giant Christmas tree all ready to go to put it back. Huge foam, but we had a time.
Yeah, so I unloaded it yesterday. It is, in fact, a very, very, very big crate. It takes a lot of space. Of course, in shipping, the shipping straps fell off and it tumbled around all over the place and smashed some things, but didn't hurt anything, which was good. Just some mortal wounds to the boxes. And so we'll be in the process of setting this thing up. I'll pass this around. So there's two charts on here. There's air, and then if you look, there's nitrogen, so N2. So air has got oxygen along with it, right? 20% air, hopefully. 20% of air is oxygen. And so if you have nitrogen only, you don't have any browning at the edges. So you'll see the nitrogen cuts are generally cleaner. However, by removing the oxygen, you remove some of the energy. So the laser isn't doing all the burning, it's actually taking the oxygen, it's oxidizing the metal, and it's releasing more heat as a result. So you can't cut things as thick if you have nitrogen as opposed to oxygen. So you'll see some limitations on what you can cut. Then they have a dual layer nozzle that can bleed in oxygen, pure oxygen, with compressed air. And so you can add, or nitrogen, and so you can add in high pressure gas with oxygen to up the oxygen concentration. And then you can burn through thicker materials. In our case, we have a CNC plasma cutter, so cutting really thick stuff isn't super desirable. We'd rather be able to cut things precisely, but I can pass this around so you guys can get a sense. The laser itself has a controller in it, and then it's got some servo motors to drive everything. It'll do 1G acceleration at the head. That was one other limitation we were running into with the test platform that we built, is that it needed to move really fast because the laser cuts really, really quickly. And if you dwell on the corners, if you slow down, you'll add a bunch of slag to the bottom, or you'll glue a bunch of melted metal to the bottom of the parts. So anyway, take a look at that. You can get a sense of what you can cut out. And like I said, it is not running at the moment, and it may not be running for a while. It's going to take me some time to hook everything up and test it, make sure it works, and kind of go from there. But maybe you got any questions? Yes.
So are you just able to hook it up to a compressed air supply and that'll make it work? Or do you need a specialized?
We need a bit of a specialized compressed air supply because the air needs to have no water in it at all.
Oh, yeah.
So when you compress air, water drops out, and then you get moisture in your air, and then that sticks to the nozzle or the optics on here. So there's a protective lens on the tip of this thing, and then there's a focal lens up here. And so your protective lens is touching the air source. So if your air is contaminated, you'll burn up the protective lens, fortunately, before you kill the focusing lens, which is like 10 times the cost. And then you also need to have no oil in it. So air compressors generally have an oil piston running up and down. So we need to have something to drop out the oil. Fortunately, our lines are pretty long. So by the time it gets to where this is, we've dropped out most of the moisture. We have a refrigerated air dryer upstairs. And we have a 3-stack filter that we run on the plasma cutter. So we should be able to get pretty clean air. However, we won't be able to hit the 220 PSI that they want. So our limit, we're going to be limited to about half of that field of cutting unless we buy a fancy air compressor.
You build an acid grade clean room.
The clean room wouldn't help us much. We need really clean air. But maybe if we suck the air out of the clean room and compress it, it would be good. Any other questions? Yep, go for it.
Well, so the fact that you can't reach that high PSI only affects the thickness of the material.
Yeah, literally only the thickness of material. It also affects if we pick the pre-generated cut behaviors, we'll probably have to slow it down a little bit because we won't be able to pierce as fast. So there's some routines in here. You can make a power curve. You can set a dwell when it pierces. So we'll have to play around with it and kind of retune it for what we've got. I do have a bigger compressor that says I can hit 180 PSI. And so if we run that one, we'll probably get pretty close to the cut parameters. We've also got some tricks to make a temporary air amplifier. So we might do that to get the last 30 PSI out of it, but we'll see if we need to. Yes.
Do you have any idea yet of what you might want to do for like running costs of like to pay for pizza?
Oh, sounds like you just volunteered. That sounds great. You can
1 cent for 10 minutes.
Yep.
So talking how like when you're doing like sharp corners and stuff, it has a little bit of overburn. Do any of those 6 options that we have now
reduce that effect?
So what it really is tuning the speed so that as you go into the corner, you lower the power down and then you pick the power back up when it reaccelerates.
Okay.
So essentially when you walk into a corner, the machine can't just go around the corner. It's got to slow down and then speed back up again. So when you do that in the laser, it'll ratio the power based on the ratio of the speed, the commanded speed. And our CO2 lasers do the same thing. There's a corner power parameter and that's doing the exact same thing.
Okay, I thought we were still running this thing at like.
So we'll see what we can do. Who knows? But unfortunately, our standard generally for laser cutting, you're doing production stuff where you don't want to have any operator attention to it afterwards. You want to cut it and have it come right off the machine. That's not what we're doing. We could care less if we take a file and clean the back a little bit. Just because we're not making tens of thousands of parts, it doesn't really matter too much.
So now we'll have multiple laser cutting machines over there?
We've always had multiple laser cutting.
Oh, I mean,
Well, we have one more multiple
Okay,
laser cutting.
right.
machine. Yep.
So typical PCB reverse engineering is done with, like, you heat a board, you remove all the components by hand, if possible, forcibly if not, sand individual layers of the board. Got a couple of different ideas about ways to peel back individual layers automatically. Do you have any idea? You said there's a cleaning function. I've seen laser cleaning where it's taking off layer of oxidation. Is that only effective on oxidation, or is that effective?
Only effective on metal, so it won't do anything at all to fiberglass.
Copper.
Yep. So it's not going to do anything on a board because you're not affecting the metal because the traces are only in small areas. You take off like a ground plane, but it would also overheat all the board layers while it's doing it. So there's some interesting things that way. They did a decap, de-encapsulation talk at the DC608 group a couple months back. Talked to Ryan. There's a guy doing reverse engineer on chip and board level stuff. So
I see lots of this. Do you know what the precision to get for cutting is on the Z-axis?
It's capacitive control, so it's got its own feedback control. So it's monitoring the board height, and then it's maintaining a focal length. That's what it's after. So it's not so much that you're fixed in plane because your material warps as it cuts. So you have to track the warping with the capacitance. It's tricky. Just half the fun. Yep. That's all right. Mark?
Is that sample board one they sent, or did it come with the machine?
That came with a machine. Supposedly our power supply cut that. In actuality, our power supply definitely didn't cut that, but they are running parts, on lasers. I imagine they've just got one setup. They're going to drop a whole sheet in, cut 50 samples, and then glue them to the board and send them along. But hard to tell. Yep.
I remember. So you talked about how the CO2 lasers can be specialized and what they can cut. Is the new fiber laser, is that like also specialized? So can it only cut metal, or can it also cut like wood and plastics materials too?
Yeah, so they've got it actually split convenient on this chart here. So you can cut metals with a fiber laser, and you can cut wood and paper and plastic with a CO2 laser, but the opposite isn't true. So you can't take a CO2 laser and do anything to metal unless it's got a ton of power and it's got that circular polarized optics. And the same thing for a fiber laser. If we take a fiber laser, it's actually a convenient way of doing check fraud, is that you use a fiber laser to erase ink. So a fiber laser can get shot at a check. It'll do absolutely nothing to the paper. You can fire all that you want, it'll do nothing to paper at all, but it'll burn all the ink off. So it's the same wavelength that's used for tattoo removal. So the frequency of light is really, really specific to do certain things. And if you use it on the wrong type of material, it just is completely ineffective because it bounces right off.
So those CS people using the lasers to remove dye from the money.
Yeah, yep, yeah. So on the cleaning function, you can put a $100 bill underwater and you can burn the ink off of it, which isn't super helpful, but it's interesting anyway. You can use a dollar bill too, I think.
Are we allowed to use it for tattoos? Yeah, right.
It would hurt
charge
a lot.
for those.
Yeah, so the tattoo removal ones, they're actually they're usually a strobe light excited fiber laser. So they have a yttrium crystal and they have strobes, and the strobe you can ramp in and out energy on the strobe light to do multiple pulses. And by doing that, you can get like, I'm gonna say tens of thousands of watts per unit area in a really controlled ramp in and ramp out. This is a continuous fiber laser, so this just like on or not on. It can't do the really fancy multi-pulse waves. But the multi-pulse waves are where, yeah, you can drill really tiny holes and things. You can take tattoos off. They do skin resurfacing stuff, things like that. Any kind of pigments it'll mess with. So consequently, this is not the same as the laser, that type of laser, but it functionally on a wavelength level it is. It's the same thing. So it would hurt like hell, and it would probably do some things, but it probably wouldn't be what you want. I'm sure some YouTubers already tried it, so you just got to look on YouTube. Any other questions? Yep.
Once you get up and running, what do you want to do with it?
Oh, you're the second person in 2 days. Does nobody have any honor around here anymore? I mean, I got to have a plan for the thing when it works. That's fine.
We've heard the check fraud part. I think that's
Yeah, the check takes care of the whole thing.
Dude, there's some things you don't say out loud.
I haven't figured it out yet. I don't know. There's like some cool shit you can make. Look at that. They got pictures right there. See, we just need some generic looking guy staring at a castle thing. We're just gonna make the castle out of metal this time. Yep.
It's able to cut marble.
The CO2 laser they're claiming can cut marble, but it'll etch marble. It's not gonna cut it though. Yeah, so this on the CO2 laser side, they're marking marble, but they're not able to cut it. Yeah, you need a water jet or a diamond router or something fancy.
Have a water jet.
We do have a water jet. It's in the state of every water jet on Earth, which is if I had a thing that I actually needed to cut with it, I could fix it. But otherwise, it needs a seal, just kind of the standard state of a water jet. Any other questions? Anybody?
It's, I assume the no, interlocking thing in this, it's all completely sealed and that.
Oh, it's got a lid interlock, and everybody on YouTube, wraps electrical tape around. They put the two switches right next to each other, so you only need one loop of tape to get them both. Yeah, no, so that was part of the reason for buying this was that the amount of work it would take us to build a high speed and closed gantry. This is much easier and faster to do that. And so yeah, it's got a lid interlock, and then the window, it's supposed to be the right window for the front. It's got the nice green tinge, so it's probably the right one. It's engraved. I mean, it says right on there it's going to be an OD6 or OD5 protection. But yeah, they got a front window on it. The rest of it's blacked out. They did put seals on the machine, so I actually tried to do a pretty good job at keeping you from getting exposed to the light. Every single video I've seen of anybody running these on YouTube sharing, what they're doing, they have the lid wide open and they're not wearing glasses at all. So yeah, it's pretty standard. I will be really interested to see, not really interested, but it'll be interesting to see how long and what happens when somebody gets hurt with these things. Because you can go online and idiot with a credit card can buy the welding source for these, which is like $4,000 or $5,000, and you can shoot it around. It's a 1,500-watt ray gun from TV. Like it's invisible, completely invisible across the room. The spot's only about this big, so you get an incredible amount of concentration even at range. I mean, the focal is not that tight, so. Yep.
There's a video of a YouTuber, the backyard scientist, where he buys, it was like $40,000, but he buys pretty much exactly one of these handheld lasers and then spends like 10 minutes just shooting something in his garage with it. So
yeah,
it's gonna be stupid, dude. Watch that video.
Yeah, it has range. It definitely has range. This will try to burn through itself. So the table's about this deep, and you need to put fire bricks in the bottom because people tried aluminum, they tried marble, they tried sand. The folks overseas say use limestone rock and then wet it every time you run it so that the rock doesn't burn too badly. So no, there's a lot of excess energy through the bottom. Again, it depends on your parameters. If you're cutting with excess energy and going too slow, you need a lot of power at the bottom. So yeah, that's the other thing we've got to do is go get some fire brick. We learned this on our laser that we were playing with. We had a tray about this deep and it cut through our material and it cut through the thing and then it tried to cut through the floor. So it really does want to go without anything in the way of it. Anybody else? Anything? All right, cool. So if you want to go around, you can say who you are, what you're interested in, and then like I said, if you're interested in a tour, we can meet by the toolboxes afterwards. Otherwise, I think for $5 you can get a go of driving the robot, shooting balls at people. Is that right? $5. Yeah, these guys are easy to motivate. So. Adrian, you want to go first?
Let me see here, I am a member. I am Marc, I'm a new member, and yeah, I play coffee and mechanic volunteer. The other project I'm working on lately is trying to fix my dryer. It's not the drum for the dryers over there. So if you want to throw out